Hello and welcome to Physics Ka Doctor. My name is Dr. Ghanshyam Tejani and let's start chapter number 14 Oscillations. And the similar content is covered under JEE NEET unit number 10 Oscillations and Waves. So first portion Oscillations is covered in the chapter number 14. And the next chapter it is to be Waves. So let us focus on sim- oscillations and this is our session number 1. What are we going to study? Simple harmonic motion. What is simple harmonic motion? The way we are going to study it. And how? We will study basic theory and of course previous year NEET question. In this session we will be having NEET questions and in the upcoming sessions we will be having previous year questions of JEE as well. Let's start. Learning outcome, what are we going to target to learn in this chapter? First, define simple harmonic motion, then illustrate it with a variety of examples. How simple harmonic motion or what kinds of motion we can define as a simple harmonic motion, and we will be having various example, nature's example. Then what next? Then relate simple harmonic motion to a circular motion. How a circular motion can be considered with the simple harmonic motion that we are going to see. Then analyze simple harmonic motion in terms of potential and kinetic energy. So, of course, when there is a motion, objects are subjected to energy, and energy portion we will be considering here in simple harmonic motion. So what next? Interpret and use algebraic and graphical representation. Algebraic, we know mathematics will be utilized, and here graphics with the use of graphs we understand how simple harmonic motion works and different examples to be solved with that. Then solve problems of simple harmonic motion, that means various applications of simple harmonic motion. We are going to study this all everything. Now a brief history of simple harmonic motions, or you can say oscillation, and the various example. You can see this all the colorful pictures that are various examples of simple harmonic motion. See, we initiated with a one directional motion, in single direction only movement, or vehicle movement, or a car movement, or then maybe a two-dimensional movement was there. A projectile we studied, when we threw a stone, what happened? It moves, take a projectile shape. And some circular motion was also studied. But see, a motion which repeats after certain interval of time, that we never studied. And in this part, we are going to study this. If you take example of this spring and mass, if you attach a spring, mass system, what happen? If you provide some displacement on this mass m, so this mass, it start oscillating, it moves in the downward direction, then it goes upper direction, then it moves right. So this up and down movement, that is oscillation, right? You can see on the seismograph waves, a pendulum of a clock, or maybe what we hear, that sound is also like that. A drum, or maybe a bridge collapse, it is also because of natural frequency or maybe movement of this universe. This all things, let's see. Now see, this study of simple harmonic motion, it is a quite older topic, and it is started with Galileo's experiment on pendulum in 1638. Thereafter, many scientists have searched a lot, and nowadays it is quite a famous topic. And by using that, We have different applications on simple harmonic motion. Then Newton and other, right? Many scientists, many researchers, many engineers, large number of people have worked on simple harmonic motion. And we have a pendulum, can be an example of a clock, or maybe a seismometer. You can see clock. There is a on the right hand side. There is a clock. We can see. We must have seen this kind of pendulum is oscillating in both the direction, and it is quite good to watch that. So that movement, it is not a linear movement. It is not a projectile motion. That comes under simple harmonic motion. Then what next? See, spring mass system. This is the spring mass system. We have observed this kind of spring mass system many a time, and this body, when we push this body in the downward direction or maybe upward direction, what happen? It moves in downward direction, then it return to its mid position, then it goes up like that. So it oscillates. Various machines, a car, a bike, driving on the road, and if we face a bump, what happens? It jump and goes down, but slightly there is some oscillation. There are some other phenomena are also there. So this all the machines, automobiles that are also working with this oscillation, and this motion is required to study. Then we can see all the vibrations, waves, sea waves. You can see here there is a sea waves which is having simple harmonic motion, maybe earthquake, right? A tide, orbits of planets, moons, acoustic. That means that whatever we heard, a sound, it is also a simple harmonic motion. Vibration of moleculars and structures. The atomic part, if we see atomic portion, the vibration, we know that there is a movement of the structure. So that is also simple harmonic motion. The musical instrument that we love to listen, that is also part of simple harmonic motion. And the collapse of bridges because of vibration, because of resonance, that also cover simple harmonic. So see, wide variety of examples are there, like that linear movement, maybe other kinds of movement. Then oscillation is also important, that we measure in terms of simple harmonic motion. You can see what is it is some deep is going on, and you can say there is some part is moving. We might have done this kind of experiment many times, knowing or unknowingly. And this motion, you can see the pendulum is moving towards left, then it is returning to its mid position, again going to its right, again returning to its mid position. And that is a simple harmonic motion, nothing else. You can see at any to and fro motion which repeats itself. That is simple harmonic motion. Motion of a pendulum. Motion of a pendulum. Now, I simply suggest that you can take a bigger pendulum by using a thread or by with the stone, you can tie with it. Can you draw certain observation from the pendulum? Is it possible for you? See, certain observations are very important to understand questions. You should find the answer and think how it works. You can see first question, where is the mass moving fastest and the slowest? If you see here, this pendulum, we can consider three position. One is mid position and another positions are two end positions. So these are the mid position and this is end position. This is also end position. Take a bigger size of pendulum and you should observe movement of pendulum. Answer these questions in the comment box. I'm not going to provide the answer for this. Next question. Where is the mass acceleration, maximum or zero. Acceleration, we know that velocity, we know that it is dx by dt, means change of displacement per unit time. And what is acceleration? Change, you can write small change, so dv, change of velocity with respect to time. Again, 3, mid position, end position, and end position, at which place acceleration is maximum, and at which place acceleration is 0. Then third question you may ask, does the time for one complete oscillation depends on amplitude? What is amplitude? What is amplitude? Yeah, that question may be new. So just it is a distance from maximum distance that travel on one side from the mid plane. We will see the distance means maximum distance travel from the midpoint, that is the amplitude. So is there any relation between amplitude, right? Is there a relation between amplitude and time? That we need to. So you can perform experiment, you can measure time, you can measure number of amplitude, and you can find relation between them. Then what causes the mass to overshoot its equilibrium position? Why this mass is going on the forward direction, maybe right hand side or left hand side? Why it is not stopping at this equilibrium position? What cause? Why it is moving? That you can answer. You can have Newton's law. We have first, second, and third. The first one is for what? Yeah. And what forces act on the mass? So we did force analysis also. So what kind of forces are there on this mass? What is unbalanced force at a maximum value? Is it 0? Answer all the questions, right? You can have experiment, right? You predict these answers and answer me in the comment section. Simple harmonic motion. Let's define simple harmonic motion. Simple harmonic motion is the simplest kind of oscillatory motion in which a body displaces from its stable equilibrium position, oscillates to and fro about the position when released. Say for example, this body, it is say for example at mid position, this at stationary. If we move this body maybe in the downward or upward, then what happen? This start oscillating. So this any to and fro motion which repeat by itself, that is known as simple harmonic motion. So by general, these are known as oscillatory motion. And the simple harmonic motion, it is also having a particular more relevant definition than the shown here. Just wait for that. So if displacement x, if I just move this system from its equilibrium position, pushing this system x in the downward direction from the equilibrium position is very small. What happened? Because of that, it generates resistive force. If I pull this body in the downward direction, because it is attached to spring, so what happened? That spring, it try to push in opposite direction. It is because of spring force, that is a restoring force, or we can say spring force, right? And this equation of motion, when simple harmonic motion is there, so spring force, it is given by spring force F. So there is a upward force on this mass. There is a upward force. Say for example, this is our spring. Is it spring? No, this is spring. When we pull this body in the downward direction with some distance from the equilibrium position x, what happened? It pull the body on the upward direction, which is equal to spring force, or you can say restoring force, which is equal to K multiplied by distance. K is a restoring force, or you can say, sorry, K is a spring constant. K is a spring constant, and the spring constant means a force required per unit displacement. Force required to stretch this spring. If I say simplify, force required to stretch this spring per unit distance. Right. So force you apply, if suppose it stretches up to this level, so that become X. Right. So multiplication force, spring force, you can say resisting force is equal to minus K, which is a restoring force per unit displacement, that is a spring constant multiplied by amount of displacement. Right. So that we know, where K is a positive constant known as a force constant in other language, engineering language. This is known as stiffness. STIFFNESS. But here in 11th, 12th, we know that as a spring constant. So we'll continue with spring constant only. But you remember that that is also known as a stiffness in NEET and JEE examination. In place of that spring constant, word can be used as a stiffness of spring. Fine. So in SI system, K express Newton, that I mentioned, that force required per unit displacement, so Newton per meter. Force required per unit displacement, so that is a Newton per meter. Now see, if the body is moving in the downward direction from the center position, so we know that force required to move any body as per Newton's law is equal to mass multiplied by acceleration. Second Newton's law. Rate of change of momentum is directly proportional to applied force, and it is effect in the same direction of force. So we know that force is equal to mass multiplied by acceleration. So if we can get acceleration is equal to a force by m. Do we have force? Yes, it is already there. Right. So put the value of F. F is equal to K by M. So acceleration is equal to minus kxm. Right. And K and M we can take, so omega square we can take is equal to K stiffness divided by mass of the body, and omega is equal to under root K by M. Omega, it is a frequency of system, right? Or you can say angular movement. Omega is equal to root K by M, and therefore acceleration is constant. So what is constant? Omega multiplied by displacement. Omega multiplied by displacement. So that is some basic equation of simple harmonic motion. Then let's have some relevant definition with the simple harmonic motion. So first is, a simple harmonic motion is a motion in which acceleration is proportional to displacement. If you see the last one, acceleration is proportional to displacement, right? Acceleration, a simple harmonic motion is a motion in which acceleration is proportional to displacement, the displacement from the equilibrium position, and second, it is directed towards the equilibrium position, right? So force is, it try to move back its mass towards its equilibrium position. So this is more appropriate definition of simple harmonic motion. And what next? Characteristic of simple harmonic motion. So displacement x in the time is given by. So simple harmonic motion, we know that it works like that. X is equal to A sine omega t plus 5, right? And simple harmonic motion can be defined as A cos omega t plus 5 over delta. We can write that is also okay. We can take, if simple harmonic motion, how, when this can be utilized. A sine omega t plus 5, say for example omega t plus 5, if theta, or you can say angle, 0. If you take pendulum, let us consider pendulum for your simplicity. This is theta, pendulum is here, pendulum is here. What happened? So if theta is equal to 0, theta is equal to 0, in sine 0, so x is equal to 0. Displacement is 0, right? So when the motion start, when the initial time starts from the mid plane, when the movement start from the mid plane, remember my word, when the movement start from mid plane, our equation is A sine omega t plus 5. Mostly by default equation is A sine omega t plus 5. And when movement starts from the end, when movement starts from the end, right? So starting condition, if x starts from the end position, right? So at the time, it is starting cos omega t delta, right? More characteristic about simple harmonic motion. So first it is amplitude. Amplitude of simple harmonic motion is the maximum positive or negative value displacement from the equilibrium position. Say for example, this body, you can see here, this body continuously moving up and down. Say for example, this is its mid position. It is moving up to this position. It is moving. Let's remove mid position here. That thus, yes, it is lowest position, and let us have, this is the highest position, and somewhere in between this is mid position, right? So it is a distance from the mid position to any of the end, and that is denoted by capital A. Capital letter is used for the amplitude. So the amplitude of simple harmonic motion is the maximum positive or negative. Both the side it will work. We can have on the downside also. A upward you can take negative, or lower you can take negative or positive. So it is a distance from the equilibrium, means mean position, to upper or lower limit of the movement. Very simple, right? So that is amplitude. If it is a pendulum, in this case also center position here. If pendulums moves up to this position, right? So this angle theta, or you can say take the distance from this, it is amplitude. So simple. Then what next? Time period, time period, time period. So the smallest time interval during which the motion repeats. So time required to repeat the motion, right? So you see body is moving from this position, it reaches, going to this, and again return back to its original position, right? So what time is required to complete this complete oscillation, right? So time required for one oscillation, or we can say time required during one repetition, that is known as time period, right? So the angular frequency omega is related to time period, as the time period is defined by capital T. Time is equal to 1 by frequency. What is frequency? Frequency means number of occurrence per unit time. Say for example, in 1 minute, how many times this system will repeat its movement, right? So frequency is equal to number of occurrence per unit time, and the time period is exactly opposite of frequency. Time required for every occurrence. Time required for every occurrence. And we can convert this into angular frequency omega. T is equal to 2 pi by omega, or we can write omega is equal to 2 pi f. Right. So these are the different equations we need throughout the chapter. And the frequency of simple harmonic motion is the number of complete oscillations completed in 1 second. The number of occurrence per unit time, that is known as frequency. This is the definition we will be repeating many a time so you can remember, so you don't have any a problem with this. Now what next? Example. Now see, we have taken the first example. On an average, a human heart is found to beat 75 times in a minute. Calculate its frequency and period. So first recall all the definition that we studied. Frequency, frequency, time period, and mega. Frequency means what? Number of occurrence per unit time. Number of occurrence per unit time. Time period, time required per occurrence. Time required for one movement, one repetition. Omega, it is angular frequency. Omega is angular frequency. Relation between linear and rotary movement. Fine. Give me what is 75? A human heart is found to beat 75 times in a minute, or you can say per minute. So can I say F? Can I say F? So the beat frequency of heart tukuk, 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 is F 75 minute power minus 1. F, we need to convert this into second because it is, we know that it is always per second. So 75 divided by 60, so we can get our value per second. So F is equal to 1.25 second. So see, calculate frequency. Frequency we got, see 75, it is also frequency, but unit is different and we cannot use that unit. We have to have per second, right? Number of occurrence per second that we have to have. Now what we required, what is our next? We need time period. Time period. So F is 1 by T. Time period is equal to 1 by F. Inverse is always equal. Then 1 by 1.25 second. And what is our solution? 0.8 second is our solution. You may check your answer. Very simple, isn't it? Before we move to the next example, let us understand velocity and acceleration in simple harmonic motion. The displacement x in simple harmonic motion at a time is given by which equation? If you remember that equation, yes, in general it is always x equal to a sine omega t plus 5. Omega is angular velocity, a is the amplitude, x it is a displacement of time. So say for example, if we consider here, this is the upper movement of the body, this is the lower movement of the body, and in between there is a movement, there is a equilibrium position. So for example, x is 0. So body is moving up and down. This is maximum value, so that is known as amplitude, right? And we can find omega, that is also is equal to 2 pi f. F is number of occurrence per unit time. You can also find t. And the phi, it we will study in terms of force vibration, means it is showing a delay in the system process. It is showing delay, but majorly now it is not useful, but let's keep this phi as it is as of now. It will come, and when time come I will explain what is phi. Wait for that. So now x is a sine omega t plus 5. Equation number 1. Now what is velocity? Velocity is equal to displacement displacement per unit time. And we also know that we can find velocity is equal to dx by dt. If equation is available, we can have a differentiation for that. And so what is dx by dt? Tell me, what is dx by dt? Here a is constant. Can we say a is constant? Of course, a is constant, so keep a as it is. What about sine? Before you do sine, we can take inner portion, so it omega should come out, omega t, right? So omega t is equal to omega plus phi is also constant, so there is no effect of phi. So sine become cos, angle remains same, omega t plus phi. Yes or no? So a omega cos omega t plus phi. So that is our velocity equation. That is equation of velocity. We can have different types of equation also for the velocity, right? So from the equation, can I say x is equal to a sine omega t plus phi? Can I write sine omega t plus phi equal to x divided by a? Of course we can write. Why not? What is the problem? No problem, dear. No problem. Sine omega t plus 5 equal to x plus a. If I want to put this value in this equation, what should I do? I need to convert this sine into cos. But how? How? Let me know that sine square theta plus cos square theta equal to 1. So we can have a square of both the side. Sine square omega t plus 5 equal to x square a square. Now what? I can put sine square is equal to 1 minus cos square theta. Let's put sine square omega t minus. So can I take cos? Can I take cos? Yes, of course. Cos square omega t plus phi equal to 1 minus x square by a, and we can write cos omega t plus phi equal to 1 minus x square. Now see what next. This is very simple. Now put this value here. So it gives us a omega 1 minus x square a square. If I take a this side, so a should be cancelled. So velocity become omega a square minus x square power 1 by 2. Velocity equal to omega a square minus x square power 1 by 2. And this equation is very important. Many a time we will be using this equation. Red color one. That's why it is red. So this is velocity relation. We can have two relation. One is equation number 2. I can put equation number 3 here as a another relation. And what about acceleration? What about acceleration? Yeah, we know that acceleration is equal to dv by dx. Yes or no? Of course. dv by dt, not x. So we have here, it become this equation. This is a omega square. What become cos become sine. Angle remains same. Omega d plus 5. And when this cos becomes sine, so it become minus. Minus. This is the equation. Minus a omega square sine omega t plus 5. So this equation, if you see here, a sine omega t plus 5, can I say it is equal to x? Of course. Acceleration equal to omega square minus omega square x minus omega square x, and this another red equation is also very important, right? Fine. So you understand now how it works. Wait. Now see, You can see there is a this corner, the body object is oscillating, moving down and up. There is a jib and how it works. So can you answer me what is maximum velocity? What should be value of maximum velocity and at what position? And what is the maximum acceleration? And it is a position. Tell me, tell me, tell me, tell me. So this is the equation, or let's change the color. Yeah. So this is the equation. What should be maximum value of this? X can be 0 omega a square. Means at mid position, velocity is maximum. And what about this? What about this? X can have maximum value a. Right? So acceleration, maximum acceleration. Tell me about position of maximum acceleration at X equal to a. X is equal to a. Is end positions. End position, maybe upper end, lower end. Acceleration will be negative, positive is a secondary matter, but it is there. Fine. Now we have example number 2. AIPMT means All India Pre-Medical Test before NEET, this kind of examination. There, example number 2, out of the following functions representing motion of a particle which represent simple harmonic motion. So first equation y is equal to sine omega t plus cos omega t. Fine. Y equal to sine cube omega t. Third equation y is equal to 5 cos pi by 3 pi by 4 minus 3 omega t. Fourth is y equal to 1 plus omega t plus omega square t square a. Right. So these are the three, and options are here. Options are first option A only. Fourth does not represent simple harmonic motion. All other are having simple harmonic motion. I don't know. B 2 and 3. Sorry, 1 and 3. 1 and 3. We don't know. C 1 and 2. 1 and 2. Don't know. And D only 1. Let's see. All India pre-medical test. Before NEET, this kind of examination system was there. See, we need to just compare, either you take y equal to a cos omega t or y equal to a sin omega t. You can take any of these two equation. Our equation should be should match with this, right? So a can have different values, like a is ultimately constant, omega have this any value, and the t is a fixed one time. So this kind of equation should be there. If you take differentiation acceleration, so it become minus a omega square, right? Cos omega t, and that we can convert this all to equation equal to a, right? So y, so acceleration is directly proportional to minus y, right? Acceleration is directly proportional to minus y. Reason is that we can write a equal to minus a y, right? So we can write not sorry, omega square y. So this kind of equations, it had to be there. So acceleration, when we take acceleration, it should be proportional to minus y. Let's see first one. If you see first y equal to sine omega t plus cos omega t. See, whenever you see both the angles are exactly matching, sine cos, we can simplify this equation. Inside this angle, you will be find omega t with some plus minus something equation, right? And when we have a sine omega t plus cos omega t, so we know that there is a 90-degree angle difference between them, right? There is always 90-degree angle between there, right? And therefore this is always a periodic. This is always a periodic. So whenever you see summation of this sine cos, and the angle is same, without any power, At that time, it is always period of function, right? So we know that sum of two periodic functions is always periodic function, right? So whenever you see sine omega t, cos omega t, it always represent simple harmonic motion, right? So this is simple harmonic motion. First is of course simple harmonic motion, right? First is simple harmonic motion. Now second, y equal to sine cube omega t. Y is equal to sine cube omega t, right? So if we write this, if we convert this sine cube omega t, so we can simplify this equal to 1 by 4 3 sine omega t minus 3 omega t. Now if you see here the difference, there is a difference angle. Here there is an angle omega t and there is an angle 3 omega t. If these angles are not matching, then it cannot be simple harmonic motion. It can be periodic, it can be repetitive motion, but not a simple harmonic motion. So it is not a simple harmonic, right? Now you just need to find angle. This angle should match. This angle should match. The plus minus sign, the angle should match. If angle is not matching, it is not a simple harmonic motion. So second, it is not a simple harmonic motion. This is not a simple harmonic motion. Fine. Now let's see third. Y equal to 5 cos 3 pi by 4 minus 3 omega t. See, whatever this value 3 omega 3 pi by 4, this value, it is 5, nothing else. Original equation is a cos omega t plus phi. Phi is known as phase angle, phase difference. It is a time required to respond the system. So 3 pi by 4, yeah, it is 5 minus 3 omega t. Yeah, it is omega t multiplied by 3, that is constant, that is okay. So it is periodic and simple harmonic motion. It is periodic and simple harmonic motion too. So now third number is correct. Third answer is correct. Now fourth. Y equal to a plus omega t plus omega square t square. So y is equal to 1 plus omega t plus omega t square. So here if you see, acceleration is should be proportional to omega square, but it is not proportional to omega square. It is also having omega t and also 1. If you take differentiation of this, so what become? Acceleration, if I take differentiation, acceleration is equal to omega square. But our acceleration should be proportional to minus y. So there is no y. There is no y. Y is missing. Here y is missing. Y is missing. Therefore, it is not periodic as well as not a simple harmonic motion. Motion is not having any acceleration. Motion is not having any acceleration which depends on t. So which are our correct answer? 1 and 3. Answer 1 and 3. Answer 1 and 3. Therefore, B is our correct answer. So that is the reason our B is our correct answer. Now, so example number 3 from NCERT book. Do not forget to solve all the NCERT examples. This build basics. Example number 3. Which of the following functions of the time represent a periodic and a non-periodic motion? Give the period for each case of periodic motion. Wow. Omega is any positive constant. Fine. So first equation is sine omega t plus cos omega t. If you see the last example, we had a similar example. Sine omega t plus omega cos omega t was there. Second is sine omega t plus cos 2 omega t. See, there is an angle difference here. There is an angle difference plus sine 4 omega t. So there is an angle difference, right? Then e power minus omega t, and fourth one is log omega t. Okay, fine. So how to identify? So first is sine omega t plus cos omega t. We know that if angle is similar, if this angle is similar, it always gives us simple harmonic motion. It gives us simple harmonic motion. Right. So displacement x in simple harmonic motion at a time which is given by x a sine omega t plus pi, and we can compare this equation. So it is answer A is simple harmonic motion. Two number is not simple harmonic motion because acceleration you cannot find relation between them, which is not equal. So this is not. Third number, when we take x, let's change the color, and x equal to e power minus omega t. If we take acceleration, so it become e power minus omega t. Acceleration should be equal to minus omega square t. So not satisfying this, not satisfying this. In similar case, log also having the similar result. So only the first answer is the correct. No other answer is correct. This case. Example number 4 from NEET 2020. Identify the function which represent a periodic motion. Similar. A e power minus omega t log omega t sin omega t cos omega t. Fine. We already solved this example. How many times? Many times. So the displacement is given by x equal to a sin omega t plus 5. Okay. So we know that this sin omega t plus cos omega t both are periodic and others are not represented. E power minus omega t no, e power plus omega t no, and log that is also not going to provide. Acceleration is equal to minus omega square t. You will never have this equation answer from that. Right. So answer number only C is the correct choice. And next question, NEET National 2019, the recent question. The radius of circle, this is our circle, of the period of revolution, initial position and sense of revolution are indicated in the below figure. Don't worry about this story, yaar. If you don't understand, that is okay. That's the circle it is showing here. Fine. Y projection of the radius, this is the y vertical line, y projection of the radius vector of rotating particle. So point which is something moving here, rotating particle which is moving from this position starting from top y, right? So options are there. Y equal to 4 sine pi by 2t, y equal to 3 cos 3 pi by t, to y is equal to 3 pi t by 2, y is equal to minus 3 cos 3 pi t. NEET National 2019, and which one is the correct? Which answer is the correct answer out of this? Let's see. So tell me, what is simple harmonic motion equation? Y equal to a cos omega t. Y equal to a cos omega t. Let's see. So here, if we compare this equation, a equal to 3. If you see the drawing, What is a? Amplitude, it is 3, and omega is equal to 2 pi by t. It is 2 pi divided by time period. 2 pi divided by how much time period? It is taking 1/4 time period. This is time period is given 4 seconds. Omega is equal to 2 pi by t. That equation we know very well. Let's again recall that equation. Omega equal to 2 pi f, and f equal to 1 by t. F is number of occurrence per unit time, and t, it is time required per unit per occurrence. Therefore, it is equation you can derive omega is equal to 2 pi by t. So now, what is our equation? y equal to a cos omega t. You can put omega is equal to 2 pi by t. Right? 2 pi by entire is 2 pi. But here it is used only t by 4. So it become pi by 2. It become pi by 2. Omega become pi by 2. Let's put here equation. So y equal to 3 cos pi t by 2 pi t by 2 and y equal to 3 cos pi t by 2. Y equal to 3 cos pi t by 2. Answer is C. The reason is that you can see arrow and it is starting from y. It is starting from y. On the y axis represent cos and x axis represent sine. That is the reason that sine is taken. Thank you very much for the physics doctor. In the next session, we will start from example number 6.